12th Max Chapter 2 Complex Numbers Exercise 2.6 Question number 1. If z equal to x plus iy is a complex number such that modulus z minus 4i by z plus 4i is equal to 1, show that the locus of z is a real axis. So two concepts are given here. Given z equal to x plus iy, it's a complex number, and also given the modulus of z minus 4i by z plus 4i is equal to 1. You have to show z is to show the locus of z, that is the path of the complex number, is real axis. That means y axis is 0, imaginary axis is 0. So let me take here z minus 4i by z plus 4i is equal to 1. So modulus of z1 by z2, the whole bar is, we can split it as modulus z1 by modulus z2. So modulus z minus 4i by modulus z plus 4i is equal to 1. Cross multiply, z minus 4i is equal to modulus z plus 4i. Replace z as x plus iy minus 4i x plus iy plus 4i. So you collect the real part and imaginary part separately. I common, y minus 4, x plus I common, y plus 4. Actually, what is this modulus of z? Modulus of x plus iy is equal to root of x square plus y square. So same thing here, you apply x squared plus imaginary one is y minus 4 the whole squared, root of x squared plus y plus 4 the whole square. Squaring on both sides. Squaring on both sides. X squared plus y minus 4 the whole squared is equal to x squared plus y plus 4 the whole squared. So x squared, apply the identity a minus b the whole squared. So y squared minus 2ab, 4 2s are 8y plus 4 squared 16, x squared plus y squared plus 8y plus 4 squared is 16. Now see here, simplify this, bring this all the term to one side, minus 8y plus 16 minus x square minus y square minus 8y minus 16 equal to 0. X squared cancel, y squared cancel, minus 16y is equal to 0. That means y is equal to 0 because 16 constant. So y equal to 0. So this is the equation of the real axis. So this is the equation of the real axis. See, we know that x-axis real axis, y-axis imaginary axis. So here on the x-axis all the y value is 0. So x1 comma 0, x2 comma 0, all the y value 0. So this is the equation of the real axis. So the the locus of z is real axis. That's all. See the second sum. If z is x plus iy is a complex number such that given imaginary of 2z plus 1 iz plus 1 equal to 0, show that the locus of z is this equation. So take the given concept, given z equal to x plus iy, imaginary of 2z plus 1 by iz plus 1 is equal to 0. These two are given. You have to show the locus is this equation. Let me take this term 2z plus 1 by iz plus 1. Replace z as the complex value x plus iy plus 1 by I into x plus iy plus 1. 2x and 2x, 2 into x, 2x plus 1 is the real value plus 2iy is the imaginary value, and here is I squared is minus 1. So 1 minus y plus ix is the imaginary value here. So let me make the denominator multiply with the conjugate of this 1 minus y plus ix into 1 minus y minus ix. This is 2x plus 1 plus plus 2iy into 1 minus y minus ix. So we know the denominator is a plus ib, a minus ib, a plus ib into a minus ib. This is equal to a squared plus b squared. So 1 minus y the whole squared plus x squared, you will get the denominator. And numerator, here split the real and imaginary part here. So 2x plus 1 into 1 minus y. Then I with I squared is minus 1, minus of minus plus 2xy. This is your real part. And collect the imaginary value, one real with one imaginary. So 1 minus y into 2y, that is 2y into 1 minus y. And then here this imaginary with real, minus x into 2x plus 1. This is your imaginary value. So we need only the imaginary of this number. Imaginary of 2z plus 1 by iz plus 1. They given this is equal to 0. This is equal to 0. So imaginary part is this. 2y into 1 minus y minus x into 2x plus 1. So 2y into 1 minus y minus x into 2x plus 1 divided by 1 minus y square, y the whole square plus x squared is equal to 0. Cross multiply. So 2y into 1 minus y minus x into 2x plus 1. Cross multiply will get 0. So 2y minus 2y squared minus 2x squared minus x. This is equal to 0. You change the sign for all the terms. 2x squared plus 2y squared plus x minus 2y. This is equal to 0. So this is what you have to prove. The locus of z is this. So the locus of z is 2x squared plus 2y squared plus x minus 2y is equal to 0.